Yes. Good afternoon, everyone.
Good afternoon, sir.
Good
Yeah.
afternoon, sir.
Good afternoon, sir.
Good afternoon, sir. Good afternoon, sir.
Yeah. Good afternoon. Our class strength is total 70. What is the total strength of this class?
So 73.
So 70.
Okay.
So 70.
It's okay. I think first unit has been completed now. Technology of water. Softening of water is completed. External methods and as well as internal methods.
Yes, sir.
So that means first unit is completed successfully. So just I would like to do the quick revision. Define hardness and its determination. Then after that, alkalinity and its determination. Boiler troubles, softening of water, external methods, internal methods. What are the external methods? Lime soda process, ion exchange method, geolite process. What are the internal methods? Carbonate conditioning, colloidal conditioning, Kalgan conditioning, phosphate conditioning. Then after that, domestic water treatment, removal of microorganisms, removal of suspended particles. Okay, so this portion has been completed successfully. Then the second unit has already started by Nariman madam, fuel and combustion. So now I am going to start the third unit. Is it okay?
Yes, sir.
Yes,
Yes,
sir.
sir.
See, in the third unit, applied chemistry, how many units are there?
4.
4 units, sir.
Yeah, what are the units?
Units 1 is technology of water, and unit 2 is fuels, combustion, and cement. And unit 3 is corrosion and phase rule. And unit 4 is lubricants and polymers.
Yeah, lubricants and polymers, fourth unit. So third unit is phase rule and corrosion. So now I am going to start phase rule unit. See, in the third unit, phase rule. What is phase rule? Then what is the application of phase rule? Small portion, but this is very, very important. 100 to 100%. This question would be there in your examination, no doubt, because this is one of the important question, and this is related to okay, engineering related topic. So this question would be there in your examination, either MCQ examination and even at the same time for your end semester examination. Now, see what is the okay, what are the contents in this? Simply, what is the phase rule, and at the same time, what is the application of phase rule to one component system? That means, say there are different systems are there. That means one component system, two component system, three component system, but the other components were not there in our curriculum. In our curriculum, only elementary level portion was there. That is the phase rule. What is the phase rule? And application of that phase rule to one component system. That was there in our curriculum. So that only we are going to discuss. Now, see, before going to that, what is the definition of phase rule, or who derived this phase rule formula? What is the background of this? That I am going to explain. See here, just okay, in broad I am explaining. The Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles to study the equilibrium systems. Okay, once again, please listen carefully. This unit is very, very important. Simply what I am saying, you listen it till end. Then at the end of the portion, you would be, okay, again, I am going to revise it. Then you would be understanding thoroughly. Don't get confused. Why it is, okay, how it is, don't think. Simply you remember, at the end, you would be understanding. Now, first of all, what is the definition of phase rule? What does it mean? What is the mathematical formula? What is the formula of that? So before going to that, I would like to give some introduction. What is that introduction? Willard Gibbs scientist, Gibbs, G-I-B-B-S, Gibbs scientist. Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles to study the equilibrium systems. How the equilibrium systems are existing in the nature. So he studied. Then, according to his understanding, he proposed one mathematical formula. He proposed one equation. So based on that equation, if you go through that equation, then automatically you would be getting the information of equilibrium system. That means if any equilibrium system is existing, then simply apply this formula over there, then you would be getting, okay, what are the degree of freedom, how many number of components are there, how many number of phases are there, that all the information you would be getting. Now, Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles. What is that mathematical formula? To study the equilibrium systems, proposed one mathematical formula. What is that? That mathematical formula is F is equal to C minus P plus 2. What is that formula? Once again, I am saying F is equal to C minus P plus 2, or otherwise F plus P is equal to C plus 2. Here minus P is there. If it is moved to left side, then that is F plus P is equal to C plus 2. Okay, the both equations are same, but you remember only one. Normally, if you remember both, you may get confusion. You remember only one equation, because in your examination, the students are getting the confusion, or otherwise some misunderstanding. Okay, small confusion. Okay, they are writing in different. That means P is equal to C minus F plus 2, like this they are writing. So to avoid that, you remember only one. F is equal to C minus P plus 2, or otherwise F plus P is equal to C plus 2. This is the mathematical formula. That's fine. See here what was written. See, it is very useful. Okay, here some introduction is there. Okay, chhod do wo. Okay, conclusion part I am very broad. See, if you go through the textbook, you cannot understand. Please listen carefully. Everything would be delivered here very nicely. Don't get tension. Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles to study the equilibrium systems. Equilibrium system means, what is the definition of equilibrium system? That means, okay, more than one or two components when they are in equilibrium, okay, in different states. If they are in different states, then that is called as heterogeneous system. That means Okay, some components are in solid state, some components are in liquid state. If those components are existing in equilibrium, then that is a heterogeneous system. If all the components are in same phase, that means either solid, then reactants are all the left hand side components are solid, right hand side components are solid. If the same phase is there, that is called as homogeneous equilibrium system. See here, okay, when the equilibrium system, any number of phases is influenced. Yes, here what it is explaining here, according to Willard Gibbs scientist. Now whatever the theory we are discussing, those are the assumptions of Willard Gibbs scientist. That means Willard Gibbs scientist predicted, then he gave all his predictions in some formula and as well as in the part of theory. So that part we are discussing according to Willard Gibbs. So what he proposed one mathematical formula, that is F is equal to C minus P plus 2. That's fine. Then F stands for degree of freedom. Simply you remember, F stands for degree of freedom. C stands for number of components, chemical components, or otherwise number of components, plus 2. F is equal to C minus P plus 2. Actually, in chemical engineering, its derivation was there. How this equation was derived? Yes, some based on the thermodynamic principles, that was there. I am taking chemical engineering, applied physical organic chemistry. In that, this derivation is there, but here the derivation is not there, so not required. Simply you remember F is equal to C minus P plus 2. F stands for degree of freedom. F denotes degree of freedom. What is degree of freedom? Yes, I will come to that point. Don't worry. Simply you remember. C stands for number of components. P stands for number of phases. That's fine. Now, according to Willard Gibbs scientist, if any equilibrium system is existing, then that equilibrium system may be does not influenced by, see here, okay, phases is in, okay, that may be influenced by temperature, pressure and concentration. He considered only 3 independent variable factors. What are those 3 independent variable factors? Temperature, T, pressure, P, concentration, C, TPC. That means, according to Willard Gibbs scientist, if any equilibrium system is existing, if any heterogeneous system is existing in equilibrium, then such type of equilibrium systems may be influenced by temperature, pressure and concentration. And at the same time, that equilibrium system does not influenced by gravitational force, electrical force or magnetic force. These are the assumptions of Willard Gibbs scientist. What is happening originally, that we will come to the point at the end of this portion. These are the Willard Gibbs predictions, Willard Gibbs scientist assumptions. According to Willard Gibbs scientist, if any equilibrium, if any heterogeneous system is existing in equilibrium, that equilibrium system may be influenced by temperature, pressure and concentration only, but it does not influenced by electrical forces or magnetic forces or gravitational force. This is the assumptions of Willard Gibbs scientist. Now, see, okay, now what is the next one is, what is the definition of phase? Or then, okay, one by one, what are the definitions? Either what is the definition of phase, what is the definition of degree of freedom, what is the definition of components, that I am going to discuss now. So till now only introduction. Now I am going to, okay, exactly original topic. What is the phase? In the mathematical formula, what is the mathematical formula? F is equal to C minus P plus 2. Everyone are following the topic?
Yes,
Are you
sir.
understanding?
Yes, sir. Yes, sir.
Yes, sir.
Be ready, please be active. Some students are sleepy mode, they are not giving reply. Please be active.
Yes. Yes, sir.
If you attentive to my class, you are not required to open the textbook. That I am saying. Please be available in the class very attentively. Yeah. See, here, what is the definition of phase? According to Willard Gibbs scientist, the definition is like this. Always, why I am saying according to Willard Gibbs? Because he only proposed the mathematical formula and he gave these type of their equations. So that we are definitions and equations. That only we are discussing. According to Willard Gibbs scientist, what is the definition of phase? A phase is defined as homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as phase. Once again, what is the definition of phase? The definition of phase is homogeneous, the system should be, the equilibrium system should be homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as phase. Once again, I am saying what is the definition? The definition of phase is homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as phase. See here, now next one is say for example, here let us take one example, water system. Here one example is there, water system. Water system is existing in equilibrium. Then how many number of phases are there? Normally, according to our knowledge, solid phase is there, liquid phase is there, vapor phase is there. That means gas phase. So let us assume that ice, solid phase is ice. So ice is equilibrium with water. That means that is the liquid phase. Then that is in equilibrium with vapor. That means what is the equilibrium system? Ice, double arrow, that equilibrium symbol. Then water, equilibrium symbol, then vapor. That means ice is equilibrium with water, then that is equilibrium with vapor. That means all the three phases are existing with each other. अरे समझ में आ रहा है ना?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Yes. See, when at what conditions the water is existing in equilibrium, which is having the three phases, that one standard conditions are there. That standard conditions are temperature is 0 degree centigrade, pressure is 4.58 mm of Hg. Temperature is 0 degree centigrade. Here 0 degree centigrade. 0. Or in some textbook it was written 0.0098 degree centigrade. Pressure is 4.58 mm of Hg. That means when here to thorough understanding of this definition, let us assume that take one transparent container, just like one white water bottle. Let us assume that, or any transparent container. You take any transparent. That means you could able to see what is happening inside of that container. Take one container, fill that container with water. Then what you have to do? Please maintain the temperature 0 degree centigrade and pressure 4.58 mm of Hg of that container. Inside of the container, maintain those conditions. Then what happen? Automatically, if the temperature is 0, or otherwise 0.0098, that means approximately that is 0 degree centigrade, then pressure is 4.58 mm of Hg. At these conditions, immediately the water, the liquid which is present in the container, that is going to existing in the equilibrium, because at that particular conditions the system may exist in equilibrium automatically. So if it is existing in equilibrium, what happen? Ice is equilibrium with water, and then that is equilibrium with vapor. That means in that container, with our naked eye, you can able to identify, yes, here in this container, this much portion is occupied with ice. This much portion is occupied with liquid. This much portion is occupied with vapor. You could able to observe the clear equilibrium system. How solid phase is equilibrium with water, liquid, then how that is equilibrium with vapor, that is gas. That means you could able to identify clearly, because as that is the transparent container, and you are maintaining the conditions are 0 degree centigrade, pressure 4.58 mm of Hg. At these conditions, these are the experimentally proved results. Don't assume that these are the assumptions. Yes, assumption means based on he did some experiments. Based on the experiments only, he gave these, okay, predictions. Okay, now see, now you come to the definition. What is the definition of phase according to Willard Gibbs scientist? Yes, according to Willard Gibbs scientist, what is the definition of phase is, if any equilibrium system is existing, then that system should be homogeneous. Yes, why he is writing homogeneous? Because the container is there, in that container water is there, and you are maintaining the conditions of 0 degrees centigrade, pressure is 4.58 mmHg. So you could able to identify which portion is solid, which portion is liquid, which portion is gas. So you come to one point, solid portion. Yes, solid portion itself, it is homogeneous. Liquid portion itself, it is homogeneous. Gas portion itself, it is homogeneous. Now physically distinct, yes, with our naked eye, you could able to see, you could able to identify, yes, this portion is solid, this portion is occupied with liquid, this portion is occupied with gas. That is a physically distinct. Now mechanically separable, yes, at that particular condition, at 0 degrees centigrade, 4.58 mm of Hg, you could able to separate all the three phases. Ice portion itself ice, liquid portion itself as a liquid, water, gas portion as a gas, vapor portion as a gas. That means you could able to separable that. And now from a heterogeneous system, if you consider that whole container, yes, that container is having solid portion, liquid portion, vapor portion. That means it is a heterogeneous system. All three different types of phases are there. So that is called as phase. So here what we have to remember, simply phase definition according to Willard Gibbs scientist, if any system is existing, then it is defined as homogeneous, physically distinct, mechanically separable. From a heterogeneous system is called as a phase. अरे वो समझ में आ गया कि नहीं आ गया? What is the definition of phase? Have you understood?
Yes,
what is
yes, sir.
What is physically
Yes,
distinct?
sir.
What is mechanically separable? From a heterogeneous system, these terms have you understood or not?
Yes, sir.
Yes, sir.
Please,
Yes,
please,
sir.
thank you.
Yes, sir.
Understand, sir?
Yes, sir. Yes,
Yes, sir. Yes.
Okay, very good. Now we have to give the phases. Phases means,
Yes,
say,
sir.
for example, water system is there. Phases, that is stands for denoted with P. F is called C minus P plus 2. P stands for phase. That is denoted with P symbol. Now, if water system is existing in equilibrium, that means all the three phases are existing in equilibrium at 0 degrees centigrade and 4.58 mm of Hg. So at that condition, how many number of phases are there?
3.
3.
3 are there. So P is equal to 3. How 3? Because solid is there, liquid is there, vapor is there. So when the water is existing in equilibrium at 0 degrees centigrade and 4.58 mm of Hg, then how many number of phases are there? 3. समझ में आ गया?
Yes, sir.
Yes, sir.
Okay. Now, say for example, water plus silica is there. How many number of phases are there?
1.
Water plus silica.
2 phases. 2, sir.
2 are there, man. Silica is nothing but sand. Sand is insoluble in water. So, water plus silica, how many number of phases are there?
2, sir.
2.
Okay. Milk plus water, how many number of phases are there?
1.
1.
Yes, very good. Alcohol plus water, or otherwise methanol plus water, how many number of phases are there?
1.
One. Because see, remember here, alcohol, the water is readily soluble in alcohol due to intramolecular hydrogen bond. Now, water plus salt, how many number of phases are there?
2, sir. 2.
1.
Here also, because salt is readily soluble in the water, but that should not exceed the solubility product. Getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
Up to some extent, it is only 1. If it is insoluble, then there are two phases. So these are the definition of phases. Here I think some examples might have given.
The two immiscible liquids will also be called two phases.
Yes. Yes.
So like oil with water will call two phase.
Oil plus
Water.
Water.
Oil.
oil plus water. Yes. It is immiscible. Okay. Yeah. Here liquid water is one phase. See here, the examples here I am reading. A system containing only liquid water is one phase. A system containing liquid water plus water vapor is a two phase because one is liquid, another one is vapor. A system containing liquid water, and water vapor and solid, that is a three phase. Then pure substances like solid, liquid and gas made up of one chemical species only is considered as one phase. Getting my point? Okay.
Yes, sir.
Yes, sir.
Okay. Now, next one is component. What is the definition of component? F is equal to C minus P plus 2. Now we discussed P. Just now we discussed P. P stands for phases. What is the definition of phase? That homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as phase. Now I am going to explain what is the definition of chemical components according to Willard-Gibbs scientist. See, according to Willard-Gibbs scientist, the definition is minimum number of independent chemical constituents, or otherwise minimum number of chemical constituents. Normally, okay, if any reaction is there, see, C stands for components. The title itself we can understand. A component means how many number of compounds are there or chemicals are there. That is nothing but components. But according to Willard-Gibbs scientist, he added one word. What is that? Minimum number of chemical constituents. Minimum number of chemical constituents that describe the equilibrium system. That means based on that you can understand what is the equilibrium system. How? What is that? See, the term component is defined as the least number of chemical constituents in terms of which the composition of every phase can be expressed by means of chemical equation. Okay, simply here the straightforward definition I am saying, but you remember the definition. Okay, see here component. Component means minimum number of chemical constituents. Minimum number of chemical constituents. Now, say for example, okay, that we will discuss later. Okay, this is very simple. We can understand. Water system. Water system means, okay, see here, at 0 degree centigrade, 4.58 mm of Hg, water is existing in equilibrium, solid, liquid and vapor. See, solid also H2O, liquid H2O, vapor H2O. Everywhere one chemical component is there. So water system is the example for one component system. अरे समझ में आ गया कि नहीं आ गया?
Yes, sir.
हाँ.
Yes.
Yes, sir.
Yes. Once again I am saying, water system is an example for one component system. Why? Because, okay, if water and vapor is only existing in equilibrium, still that case also one component, or otherwise ice, solid, vapor, all the three phases are existing. Still in that case also, how many number of components are there? Only one.
One.
Or otherwise, then ice and vapor, these are in equilibrium system. How many number of components are there?
One.
Only one.
That means chemical components are H2O only, so one component system. Now, similarly, sulfur system has four phases. What are the four phases? Rhombic sulfur, monoclinic sulfur, liquid sulfur, and sulfur vapor. But all these composition is only sulfur. They are existing in different phases. Okay, what are those phases? That rhombic sulfur is there, monoclinic sulfur is there, liquid sulfur is there. But in that, what is the chemical component? Chemical component is only one. Yes, sulfur. So hence, the sulfur system is also example for one component system. अरे समझ में आ गया कि नहीं आ गया?
Yes, sir.
Yes, sir.
Yes,
See,
yes.
water is existing in three phases: ice, water, and gas, liquid, vapor. So there, how many number of components are there? Only one, H2O is there. Similarly, sulfur is also existing in different phases, but chemical component, if you study the chemical structure, everywhere sulfur is there. So sulfur system is also example for one component system. Yes. Then another one, another example. What is the another example? Here, decomposition of calcium carbonate. Decomposition of calcium carbonate that gives rise to calcium oxide plus carbon dioxide. So looking to this structure, this is a well-known chemical reaction, decomposition reaction. Here, looking to the structure, how many number of chemical components are there?
Three.
Three are there. Looking to equation, one is calcium carbonate, that is the solid. Then calcium oxide, that is also one chemical component, solid. Then carbon dioxide, that is the gas. That means, okay, two solid components are there. Then another one is gas is there. This here, looking to this decomposition reaction, we are assuming that three chemical components are there. That is true also. But according to Willard Gibbs, scientist, what he said, the definition, minimum number of chemical constituents. Minimum number. Minimum, if you know, so minimum number of chemical constituents, that means if you know the minimum number of chemical constituents, then automatically you can predict what is the other chemical component. You are not required to disclose all the three components. You are required to disclose only minimum number of chemical constituents. If you know the minimum number of chemical constituents, then automatically we can predict what is the other chemical components which are present in that equation. So this is the definition of Willard Gibbs scientist. So according to Willard Gibbs scientist, here how many number of components are there? Two. How? See here, let us assume that calcium carbonate minus CaO. Then what is the third chemical constituent? Hello? I am asking one question. Calcium carbonate minus calcium oxide, that gives rise to?
Carbon dioxide.
Only. Because these are the standard equation, experimentally proved reaction. The decomposition of calcium carbonate is going to produce calcium oxide and carbon dioxide only, no doubt at all. Now, if I will ask like this, calcium carbonate minus carbon dioxide, that gives rise to?
Calcium oxide.
Calcium oxide. Very good. Or otherwise, calcium oxide plus carbon dioxide, that gives rise to?
Calcium carbonate.
Because looking to that, you can understand that is the decomposition of calcium carbonate. That means if you know the two components, then automatically you can predict, you can guess what is the third chemical constituent. Exactly that is happening here. He considered that one. That means because of that, he gave the definition minimum number of chemical constituents which describe the other components of the system. That means here the decomposition of calcium carbonate is there. Looking to the equilibrium system, looking to the reaction, the three chemical constituents are there. But according to Willard Gibbs scientist, we have to say minimum number. So minimum number is 2. Because if you know the two chemical constituents, automatically you can predict what is the third chemical constituent. That means if you know, let us assume that you take one only. Calcium carbonate gives rise to. But you can understand whether that is decomposition reaction or otherwise what type of reaction it is, you don't know. But if you know, that means particularly to this reaction I am discussing. If you know calcium carbonate calcium carbonate minus CaO, then 2 are there. Then what is the third chemical constituent? Carbon dioxide. Looking to that, you can understand that is a decomposition. Other calcium carbonate minus CO2, then that is going to produce the calcium oxide. That means every time minimum you are required to. If you know the two chemical constituents, then automatically you can predict third one. So here, how many number of components are there?
2.
Two chemical constituents are there. Now, so that is the that is another example. Another example here I am discussing ammonium chloride that gives rise to ammonia and plus HCl. See here, ammonium chloride when heated in a closed vessel dissociates into ammonia and HCl gas. The system has two phases: solid ammonia gas and contain ammonia chloride. However, the constituents of the mixture are in the same proportion in which they are combined in solid ammonia chloride. The composition of the both the phases, therefore, they are expressed in terms of same chemical individual ammonia chloride. Thus, the dissociation of ammonia chloride is one component system. See here, what is happening? What does it mean? The dissociation of ammonium chloride is example for one component system. How it is one component system? You may be having the doubt. What is the doubt is, sir, looking to the chemical reaction, ammonium chloride solid is there. That means that is the phase. Ammonia gas, that is also one phase. HCl, that is also gas. At least if you consider solid as a phase, gases are as a phase. So solid one phase is there. Gases are also two are there. At least two components it should be. But here, according to Willard-Gibbs scientist, here it is the one component system only. Why it is one component system? Because always the dissociation of the ammonium chloride that is going to produce the ammonia and HCl in a closed vessel, and then in a closed vessel, then that is going to the ammonia and HCl, they may mix up and that is going to produce the ammonium chloride only. That means that is one component system. Here you remember. That means simply you remember for decomposition of calcium carbonate, two components are there, and at the same time for ammonium chloride only one component is there. And water system, how many number of components are there in the water system?
1.
One component, because everywhere H2O is there, so that is the component. So what is the definition of component is there? Minimum number of chemical constituents that describe the other chemical components, or otherwise with the help of that we can able to discuss the equilibrium system. That is the definition of component. The next one is degree of freedom. Alright, can I continue or can I stop it? How much time is
Excuse
there?
me, sir. So 10 minutes.
How much time is left?
10 minutes for next class.
11 minutes. After 11 minutes, class will continue. Mathematics.
So can I continue for 10 minutes?
Yes, sir.
Yes, sir.
Yes, sir. You can.
Okay. At least today, I would like to complete at least the definitions of the mathematical formula. Now, next one is
Can you show the previous slide?
which one?
Sir, can you show the previous slide?
This
Previous
one?
slide. Dissociation. Sir. Okay, sir.
Now,
sir.
next definition is degree of freedom. What is the definition of degree of freedom? The degree of freedom is minimum number of independent variable factors, temperature, pressure, and concentration should be specified in order to describe the equilibrium system. See, at the beginning I said, what are the Willard-Gibbs assumptions? That assumptions are, if any equilibrium system is existing if any system is existing in equilibrium, then that system may be influenced by temperature, pressure, and concentration. He considered these three independent variable factors. That means if any system is existing, then that system may be influenced by temperature, pressure, and concentration. Those are called as independent variable factors. That's fine. But here, again, he added one word, that is the minimum number of independent variable factors. That should be specified in order to describe the equilibrium system. If any system is there, then for that system, you are required to fix how many number of independent variable factors are there. Then automatically you can predict other independent variable factors. That is the definition of Willard-Gibbs scientist. Okay, let us assume that. Okay, that is denoted with F. If F is equal to 0, that is non-variant. If F is equal to 1, that is monovariant or univariant. If F is equal to 2, that is bivariant. Okay, bivariant. Then then later we will discuss. What is triple point? That we will discuss at the application point. Now, once again, F is equal to 0, non-variant. F is equal to 1, monovariant, or otherwise univariant, bivariant. That means 2. That is, see, monovariant or univariant means one independent variable factor should be specified. 2 means 2 independent variable factors should be specified. Okay, that we will discuss. Now, let us assume that one system is existing in equilibrium. Water is equilibrium with vapor. Let us assume that this is one system and this system is the equilibrium system. Water is equilibrium with vapor. That's fine. Now, based on the experimental results, at what conditions water is in equilibrium with vapor? What are the experimentally proved results? Yes, experimentally proved conditions. Temperature is 100 degrees centigrade. Pressure is 1 atmosphere pressure. At this condition, water may equilibrium with vapor. Once again, remember, boiling point of water is 100 degrees centigrade. Pressure is 1 atmosphere. Then only water starts boiling. These are the experimentally proved results. Everyone agreeing or not?
Yes, sir.
Yes, sir.
Because see, water is equilibrium with vapor means water boiling. It starts boiling at 100 degrees centigrade and that water is equilibrium with vapor. Now, according to experimental results, what are the conditions? Temperature is 100 degrees centigrade. Pressure is 1 atmosphere pressure. That means 2 conditions are required to describe this equilibrium system. This is normally. But according to Willard Gibbs scientist, his assumption is we have to specify one independent variable factor. See, first of all, what are the independent variable factor? He considered only temperature, pressure, and concentration. Out of these 3, he is saying that if you know, one independent variable factor only we have to specify. Then automatically we can guess other independent variable factor. How? See, let us assume that water is in equilibrium and temperature is 100 degrees centigrade. Don't discuss about pressure. Once again, water is equilibrium with vapor. Temperature is 100 degrees centigrade. What about pressure? Pressure must be 1 atmosphere pressure, because what you are saying, water is equilibrium with vapor, and at the same time you are specifying one component, that is temperature. You are specifying temperature is 100 degrees centigrade, so automatically pressure is 1 atmosphere pressure, no doubt at all. These are the experimentally proved results, so don't get any confusion in your mind. So according to Willard Gibbs scientist, how many number of degrees of freedoms are there here? 1. That means one independent variable factor should be specified. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir.
Yes, sir.
Everyone, please reply.
Yes.
Yes, sir.
Yes,
So
sir.
definition is
Yes.
minimum number of independent
Yes, sir.
variable factors should be specified.
Yes, sir.
Okay. Once again, I am saying water is equilibrium with vapor. What about temperature?
100 degrees Celsius.
100 degrees centigrade only, no doubt at all. It cannot change. That is a constant. That means if you know one independent variable factor, then automatically you can predict other independent variable factor. Let us assume that water is that is so here F is equal to 1. Hence it is monovariant or univariant. Then another example I am giving. What is that? Another example is if all the 3 components, that means water, water is equilibrium with, here I am going to put Let us assume that ice is equilibrium with water and that is equilibrium with vapor. That means all the three phases are existing in equilibrium. So what are the conditions?
0 degrees Celsius and 4.5 mmHg.
Yes, that means temperature is 0 degrees centigrade, pressure is 4.58 mm of Hg. Here F is equal to, that means here for this system, degree of freedom is equals to, just tell how many number of degrees of freedoms are there?
1.
Only one.
Okay.
2, sir.
This is,
0.
2, sir. It is supposed to be 2.
okay, 2. No problem, you can give your answer. But according to Willard Gibbs scientist, here F is equal to 0. Why F is equal to 0? Why degrees of freedoms are 0? Because we have to express minimum number of chemical constituents. Minimum number of chemical constituents means, see, simply I am saying like this. Water is existing in equilibrium with all the three phases. That means you are not required to specify the temperature and as well as pressure. Simply you say like this. Water is equilibrium with all the three phases. That means temperature is 0 degrees centigrade, pressure is 4.58 mm of Hg. So you are not required to specify either temperature or pressure. So hence F is equal to 0. That means this is a non-variant. Non-variant means you cannot vary either temperature or pressure. If you vary the temperature, then what happens? Then ice may convert it into water. Then ice phase does not exist, or otherwise, okay, if you reduce the temperature, if you vary the temperature, if you reduce it, then what happens? There would be no vapor phase. That means they are the constant. You cannot vary either temperature or pressure. So hence here it is non-variant. You are not required to specify also. You are not required, okay, the temperature is this much, pressure is this much. That is by default it is understood. Water is existing in equilibrium with all the three phases. That means by default temperature is 0 degrees centigrade, pressure is 1 atmosphere pressure, 4.58 mm of Hg. Hence that system is non-variant. Non-variant. 0. F is equal to 0.
Sir?
F is equal to 0, non-variant. Okay. Then if F is equal to 1, that is the monovariant. Monovariant. Okay, bivariant system is there. Trivariant systems are there. Different systems are there. Okay, bivariant systems are not available. Okay, in our syllabus. Don't discuss. Yes, here. Okay, some ideal gas equation was there, but don't remember that. Simply how much it is there in your portion, you go through it. Bas.
Sir?
So,
So for a case of like ice is equilibrium with water and a vapor, all three phases equilibrium. We are saying that because we know that such condition requires us to have a specific pressure and a temperature of 0 degree. So because we know the temperature and pressure, hence we have a non-variant system. Sir, for a system of water equals to vapor, the first system we were talking about, sir, in that also we know that the pressure is 1 atm. Else, if the pressure is not 1 atm, then there will be no equilibrium between water and vapor. Similarly, if the temperature is not 100 degrees Celsius, water will not boil. So why is there F equals to 1? Why is that? What is exactly a degree of freedom in that case?
No, if that is the case, if the okay, your doubt I understood. What is your query? I understood. But here what happened? Okay, here what happened? Water, when it is equilibrium with vapor, you must specify one independent variable factor. Why you must specify one independent variable factor? At the time of application point of view, when we are discussing the one component application, one application of phase rule to one component system, that time you can understand thoroughly. Or otherwise, okay, let us assume that what is there? See, let us assume that. Yes, okay. Just briefly, I am explaining. Okay, here one graph is there. Here, C, T, A. This portion is occupied with solid. C, T. Okay. Let us assume that here another TC is there. This much portion is occupied with liquid. this much portion is occupied with vapor. Let us assume that water and liquid are in equilibrium. Then, okay, you must specify one. Okay, that time I will explain, okay, why it is required. Okay, don't worry. समझ गया आपका doubt समझ गया. Okay, now you remember this much only. Okay, at the time of while discussing the application of phase rule to one component system, I will explain that point.
Okay, sir.
So now my conclusion, today's class conclusion is, what is the mathematical formula of phase rule? F is equal to C minus P plus 2. In that, F stands for degree of freedom, C stands for number of components, P stands for number of phases. See, according to Willard Gibbs scientist, degree of freedom, he considered only 3 independent variable factors, that is temperature, pressure and concentration. So you must specify for any equilibrium system temperature, pressure and concentration only. Then components means how many number of chemical constituents are there, chemical components are there. Then phases means whether that equilibrium system is having how many number of phases, that means solid phase, liquid phase or vapor phase. So the definitions we had discussed. The next class, the application of phase rule to one component system, that we will discuss. At least the definition and what is the phase rule, this understood or not?
Yes, sir.
Understood.
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
See, don't go in deep. Simply, what is the mathematical formula of phase rule? F is equal to C minus P plus 2. F stands for degree of freedom. P stands for number of phases. C stands for number of components. What is the definition of number of components? Minimum number of chemical constituents. Then what is the definition of phase? The phase is defined as homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as a phase. What is the definition of degree of freedom? Minimum number of independent variable factors should be specified in order to describe the equilibrium system. Like this, you remember only. Okay. Then, okay, day by day, that means at the end of the portion, we can understand thoroughly. In our curriculum, they could have incorporated the two component system. There are at the same time 3 component system. It is a very big portion. Here, one component system, the 2 water system was there. Even sulfur system was also not there. Sulfur system is also example for one component system. But that application is also not incorporated here. But in chemical engineering 4th semester, that topic was there. One component water system, sulfur system is there. Then 2 component silver iodide system is there. In 2 component also 3 or 4 examples are there. And each system is having unique explanation. But here very simple topic was there. Define phase rule and explain the application of phase rule to one component system. In the one component system, water system is example for one component system. And only one component system, water system was there in our curriculum. So water system is sufficient. That means that is there in our curriculum. So that only I am going to discuss. Okay. Can I leave the class?
Yes, sir.
Sir, thank you, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Attendance.
Sir, attendance.
I took screenshots.
Okay. Sir.